alaikum. My name is Ritaba Khan, and the topic of my presentation is tea-maize alternation. So, tea-maize can be used in a variety of ways to access the cognitive ability of an animal. The sight arms can contain discriminative stimuli, different stimuli such as patterns or objects that the animal must respond to generally to obtain a reward. There is a large proportion of research to cognitive focuses on the hippocampus because there is a major site of pathology in the Alzheimer's disease. And when even the hippocampus is removed or damaged, animals can generally solve very difficult reference memory problems because as there is no spatial component. Reference memory tasks in the T-maze are therefore of limited value in assessing the animal Alzheimer's disease models. As it is a natural tendency of rats and mice in T-maze, however, it is to alternate their choice of goal arm. They are using the working memory, that is, they respond to a different trial varies according to what they have previously just done. Alternations show the motivation of an animal to explore its environment or area and to locate the presence of resources such as water, meats, food, or shelter. And animals do not need to be deprived of such resources to show alternation behaviors. So, in this case, it is called spontaneous alternation. Um, Basically, it is a behavioral test for measuring the exploratory behavior of an animal, especially rodent models for CNS disorders. As in previous, I told you Alzheimer disease. This test is based on willingness of rodents to explore a new environment because so they prefer us to visit a new arm of the maze rather than a previous arm or a familiar arm. There is involvement of many parts of the brains like hippocampus, septum, basal forebrain, and prefrontal cortex are involved in this task. Moreover, alternation, whether it is rewarded or spontaneous, it is very good in detecting the hippocampal dysfunction and even more better than the Morris water maze. The septal hippocampus system is involved, including cerebellum, thalamus, and substantia innominate. And even the blind animals can show alternate successfully, showing that there is also involvement of vestibular system. Many neurotransmitter systems have been implicated in the alternation behavior. Spontaneous alternation is impaired in mice infected with the Presence disease. Um, First, the subject are placed in the start arm of the T maze, and when the animal leaving the start arm, animals must have to choose either left or right goal arm. With repeated trials, the animals show least tendency to enter a previously visited arm, and the percentage of alternations means number of turns in each goals and the total try durations are recorded. This test is used to quantify the cognitive deficits in transgenic strains of mice and evaluate the novel chemical entities for their effect on cognitions. There is um, article on T-maze alternation in the rodent. Spontaneous alternations run similar to rewarded alternation, but there is exception that there is no habituation to the maze is used, as it is novelty of the maze that drive the spontaneous exploration. And the normal protocols allow a free choice of goal arm on both samples and choice trials. And in as in the rewarded alternation, one arm is blocked off and predetermined sequence of the sample arm is used. In principle, either a predetermined or free choice procedures could be used for either paradigm. There's an advantage of free choice procedure that in the hippocampal lesion, animals can develop a side preference. So um, we know that we come to know that there is a hippocampal lesions, and so the control hippocampal differences would be larger. The procedure is that first we have to set the maze so the central position is placed and all guillotine doors are raised, and place the animal in the start area and allow to choose a goal arm. Confine the choosing arm by quietly sliding down the door, and after 30 minutes remove the center partitions to and remove the animal. Raise the door of the sample arm and replace the animal in the start area facing from the goal arm, and allow the animal to choose from between the two goal arms. As with rewarded alternation, each trial should take no more than 2 minutes. 1 minute is the minimum possible. Data analysis is that for experiment with a small number of trials, a percentage per animal can be calculated, and the result um compared using the control and treatment groups. For longer experiments, block the data into suitable portions like 5 or 10 trials. Blocks are suitable and perform repeated measures ANOVA. There's a protocols also for the spontaneous alternations. So we recommend a change of floor or door every rounds of trials, as otherwise the mouse lose the motivation. Some also put a fresh piece of paper under an open floor maze for each trial. If the animal double back at the choice point on the sample trial, don't use the start arm door to stop it. Doing so would simply create a cozy corner in which animal would probably sit and not explore any area of the goal arm. Instead, just put your hand near the animal so animal would start to run away from the into the goal arm without push the animal. The main use of the start arm is to retain the animal ready for removal after a choice has been made. Once the choice criteria has been passed, lower the goal arm door opposite to the chosen. The animal will exit the chosen goal arm and enter the start arm. Then the door of the latter can be lowered, confining the animal to the start area from whether it can be removed. Hence, if removed is aversive, this negative effect will be confined to the one area of the maze where it be beneficial to the experimenter. There's an also disadvantages of the spontaneous alternation, and there is several disadvantage. The one is that the continuous nature of the task means there is a lot of inter-trial interference, and there is probably the main reason why alternation rates are more than 65% or less is typical. The other disadvantage is that the task may fail to detect the hippocampal damage. Hippocampamized animals notoriously adopt site preference, so we can detect the hippocampamized animals but not detect the hippocampal damage. Result is that if these procedures run correctly with a suitable rat or mice control, generally achieve at least 30% correct alternation and often higher. Conversely, it is rare for animals with complete hippocampal lesion to score above 60% over a number of trials. Thank you.